Well, hello, friends, and Merry Christmas. Today we are going to look at some hardening stuff. After the HXP CTF, a bunch of issues have been cropping up, and Brendan has reported some really interesting ones here on the bug tracker about the memory layout of setuid programs being accessible even after they drop privileges. And that's something that is not a very good thing because the first of the two exploits from HXP was using the fact that the dynamic loader was at a predictable address. And then we started randomizing that address. But if you can still go here and look at the memory layout of a setuid program, that kind of makes that randomization useless because well, let's just test it out here so we can see for ourselves. So SU is now, of course, running as root, and it's waiting for me to type the root password. And if we look here, then the SU process has anon as the user because that's the UID. Although it is running with root as the effective user ID, we use the base UID as the user that we show here, and we can also see the full memory layout of the SU program. So the fact that we have randomized the loader base address here and loaded it at hex DEB1 000, it's completely irrelevant because we have that information right here. So the randomization achieves nothing, basically. So we need to protect this information. So the first and obvious thing that we should do, I think, is to just have the, so all of this information comes from the proc file system, by the way. So this is /proc PID 26. So let's go look at that. Oops. 26. Yeah, so we can look at the VM here. This is all of the memory regions in this process. And actually, Brendan added a nice tool for showing in a very readable text format this type of stuff. So yeah, we can see that the loader is right here at DEB1000. And if we look at the directory permissions for proc26, we see that they are this directory is owned by a non, even though it is actually running as EUID 0. So yeah, so let's start by making this thing owned by the effective user ID rather than the user ID. And then we're going to look at some other things that also came up here in the discussion, because Brendan has some more suggestions which look really nice. But we'll be starting with UID. So let's see, where is this? Yeah, so the metadata for a procfs inode uses the current process, or no, not the current process, the process that we're looking at. If it's a process-related file, then we get the process that it relates to, and then we ask that process for its UID and GID. But really, we should be using the effective user ID and effective user group, I think. So let's use the effective user ID, and effective user group is thread-related file. Yeah, let's do the same thing for those. Okay. So I think this should definitely be a progression. Well, let's take a look. First up, oh yeah, so root doesn't normally have a password, so we have to set one. Just set foot, root foot, and then SU, and we go here and look. And now process cannot be accessed because oh, right. Command-Shift-N in the terminal is broken. We need to fix that, but that's a separate issue. So proc, and what was the PID? Is it 29? Yeah, so now it's owned by root instead. Even though I started the process, it's owned by root because it's the effective user ID. So that seems like a pretty reasonable change already. And let's commit that. Kernel, make proc PID directories owned by the UID EGID. Instead of the UID GID, since that was allowing some very bad information leaks, like spawning SU and as an unprivileged user and having full access to it via proc. Yeah. So this is work towards, let's say, 4504. Yeah, so as Brennan says here, this doesn't seem right and reveals the memory map and stack, including the loader base address. Yeah, so very, very bad stuff. And my suggestion here was that we should use the EUID EGID. So now we do that. And then Brendan brings up this dumpable flag that Linux has. So they have something called a dumpable flag per process, which it determines if core dumps are produced for the process. And it also controls, let's see, I think it controls access to proc PID files somehow. The files inside each proc PID directory are normally owned by the effective user and effective group ID of the process. Right, just as we do now. However, as a security measure, the ownership is made root if the process's dumpable attribute is set to a value other than 1. So I think this makes a lot of sense. Basically, we will have a flag that sort of excludes a process from inspection by anybody other than root, and then we will set that flag. Any process can opt into the flag, and then we'll also automatically set it for set UID and set GID processes. I think that makes some sense. And what do we have going on here? Normally the flag is set to 1. However, it is reset to the current value contained in. Okay, so it falls back to like the system default. We don't need to do that one. We don't need to have a system default for it right away, but I mean, we can just have it like a hard-coded default. We don't need to have it configurable. But it seems like they go into the restricted mode whenever you change your EUID or EGID, or your file system UID or GID, or if you execute a set UID or set GID program, or if you execute a program with capabilities something. Processes that are not dumpable cannot be attached via ptrace. That's cool. We should have the same behavior. Yeah. Yes. So I think this seems very, very, very sensible. So let's go ahead and implement these behaviors as well. So let's see. Let's say that process gets a dumpable flag. Where do we put that? maybe here next to the PPID. Dumpable. Okay. So far, so good. Not the most exciting stuff, but we got to start somewhere. So let's see. Doesn't really matter where we put this kind of member. So by default, it will be true. And then let's see. When we exec a setuid program, so muid equals, where do we do this? Here. Yeah, so EUID is, yeah, so for setuid programs, then we will say that if muid is not main program description UID. So if it changes in some way, or you know what, let's just say always non-dumpable at this point. And then we can probably unrestrict some of this stuff later, maybe. Okay. That seems good. And then in ptrace, we should disallow dumpable things to be attached to. So where is that? If peer process is dumpable. If it's not dumpable, return kresult access. Yeah. Okay. And then in procfs, here, let's see. So if thread or thread process is not dumpable, if thread and a thread is dumpable, then yeah, same thing. If process and process is dumpable, otherwise we'll fall back to 0, 0. So I don't think we need a to-do about that. This makes perfect sense to me, that these files are owned by 0, 0 if something is, if there's any reason not to expose them normally. Okay, so that's pretty good. Let's see, so we still don't have any control over this flag. Let's expose it somewhere. Maybe in the proc.all thingy. So here we can include this in the big process data dump thingy. Dumpable. Okay, so wait, where is SU? This is not optimal. Maybe we should implement a search function in the terminal so I can search backwards. It would be nice if I could load this into, okay, this is really stupid. If I could load this into a JS console somehow, that would be pretty magical. Well, how hard would that be, actually? If I have this and I copy that, then I start a JS and I paste it. Oh. Oh, I didn't like that. Okay, well, that's a separate investigation. Let's not do that right now, but it would be cool if we could make that easier. Because we have all this JSON and we have a JavaScript interpreter, so why don't we put them together? But anyway, that was really tedious to look at it that way, so let's look at it this way instead. Grep su. Did this just hang? Oh, come on, man. Come on. What is this? Okay, so that needs to be fixed. Okay, su, please. This is really cumbersome. Okay, so here we have su, and it is not dumpable. Cool. And is everybody else dumpable? Yes. Great. Wow. This was, I think we just discovered like 10 bugs in the span of 60 seconds here. Okay. Phew. Let's just push forward and ignore all of those things right now. So now we want something like Linux has, where we can call a syscall to set this flag so that we can tweak it. So pr set dumpable. Do they also have get dumpable? I guess they do. Yeah, okay. So it's prctl. It's not something we have, but it's something we could have. Operations on a process or thread. I see no reason why we shouldn't have a syscall like that. So let's just add one. It's essentially int sysprctl PID. Or no, it's on the calling. Oh, it's only on the calling process. Okay, that's cool. Okay, fine. Let's just mimic their style. But we can do 2 arguments, I don't think, or 2 arguments to the option, 3 arguments total. I don't think we need to mirror completely what they do because it's I'm assuming this is a Linux specific thing. It doesn't feel like a POSIX API. But still, it's nice to have something like that. So let's see. Syscalls. Let's copy ioctl maybe to prctl. Let's put it here. Prctl. Okay, prctl. Cool. And then switch option, I guess. Default, return enval. But if you tell us something interesting, like, what do they call that? PR set dumpable or PR get dumpable. In both of these cases, we don't need any of the arguments, so I think we'll just do this for now. Or actually, in the set case, we need the first one. Is dumpable. Boom. And set dumpable. arch1. Something like that. Although, what's the access control here? Set dumpable. I guess it doesn't need access control because it's the process itself doing this, right? So you're not doing this to another process, it's the process itself. So I think we can always allow it. Okay, so this was in 2020. Let's see. So prctl numbers maybe, yeah. Just setting up the libc headers for this. IOCtl is right here. Okay, okay. Do we really need these to be in enum? I don't know. It seems kind of weird, actually. Yeah, this also seems fine. A very uninteresting header, actually. Yeah, I think we don't want to do this type of API here. Let's just do let's just do something simpler. Okay. This is kind of tedious because we're just stubbing out everything, but we are basically finished. Okay, great. Oh, and we forgot to wait. Why does it have different language linkage? Is it because my editor is in kernel mode? Yes, it was. Okay. Yeah, so now basically we've just created a way to make yourself undumpable, if that's something that you want. So who would want to be undumpable? Not super sure. Let's just try it on something. So what if we do it to cat? Let's just say prctl. set dumpable false, right? So we just do that. Cat. And then we try to look at the cat process. Does it work? It doesn't work. That's pretty cool. And I keep forgetting about the Control-Shift-N problem in terminal, but ignoring that. So cat is 26. 26 is permission denied, but we can look at it here, and it is indeed owned by root. That is pretty cool. Yeah, so the effective user or group ID is changed. Or if it executes. Yeah, so I guess we could also do this when you do a set UID. Because why not? Set dumpable false. Let's see, if MUID is not UID. Okay. To cover all of these since we're here anyway. Makes me wonder, maybe we should encapsulate this better in a function or something, but this seems like a decent enough start. So when you're changing the EUID or EGID, we will now make the process undumpable. Okay, and then of course we should also make sure that we don't dump core. So dump core. We have set dump core, but then where do we actually dump the core? Core dump create. So let's look for those. So here we have create for process. So I think if process is dumpable, if it's not dumpable, then sorry, we cannot create a core dump. Refusing to generate core dump for a non-dumpable process. Process PID. Cool. Okay. So then what happened? We have a ring 0 crash. Oh, is that some random thing that just happened on startup? Yes, it was. Okay. Well, I haven't seen that one before, but it's interesting. So we're crashing in K-free. I don't know what that one is. It's an invalid write to a kernel buffer somewhere. Looks like we're about to, like we're just releasing some kmalloc heap memory and then we're trying to write to it soon after. That's an oopsie. K-free is doing this. Why is K-free doing that? K-free. I wonder if it's something obvious. It's probably not something obvious. I'm just kind of curious now. Non-null own putter. Yeah, let's not get distracted. Okay, so let's see. Did we achieve all of these things? You changed the EUID or EGID. This one we don't have. If you execute a setUID or setGID program, and capabilities we don't have, ptrace attach is not allowed, and the ownership of files in proc PID are affected as described here. Where is that stuff? Okay. So if you reset the dumpable flag, then they should become visible again. That makes sense. Therefore, it may be desirable to reset the dumpable attribute after making any desired changes to the process effective UID or GID. Sure. So let's see. I guess like anything spawned by the system server, because system server will switch the user to whoever is specified here when launching a service. So, for example, with something that I own here, anon system menu, right? Like this thing up here. Can I actually look at that process? System menu, let's take a look. No, it's not dumpable. That's interesting. So it's not dumpable because system server had to fork and then set UID to become anon, and by doing the set UID, this process became non-dumpable. So that's working as intended. But I think maybe we should be nice about this and like mark them dumpable again. So where do we do that in the system server? Here is dropping privileges to the right user. So I think here we will just say, we'll prctl here, prctl. Or if we can't make the process dumpable, that's not a fatal problem, I guess. It's not the end of the world, so yeah, let's just tolerate that. But we can log that something was weird, but it's not the end of the world. Okay, so now system menu should be dumpable, so we should be able to see it here. Yes. That's pretty sweet. Okay. But SU should definitely not be dumpable. Yep. Kick ass. It's not dumpable and it's owned by the effective user ID anyway. But if I launch a shell here, this shell, also not dumpable. Good. What if I become anon? This shell. This shell is not accessible. Should it be? Maybe it should be. This opens up so many questions. I guess once we execute and make a shell here, should it be dumpable? I don't know. That's an open question. Should SU make it self-dumpable before execing, because then you're introducing a race, right? Like where you can inspect the memory layout of SU before the exec. I don't love that. So is it up to the shell to make it self-dumpable on startup? That's also a little bit weird. I don't know what the correct solution here is. If somebody knows, then please let me know. But I think right now we can just err on the side of things being non-dumpable a little too much, and then we'll have to like improve on that by sort of scaling back the amount of restrictions that we put. And let's not have that cat change. But all the other changes we do want, I think. Yeah, this is very cool. Or shit, let's revert that change here to system server and do that one separately. Kernel plus libc. Oh. Introduce a dumpable flag for processes. When a process is dumpable, this flag, this new flag, controls whether the kernel will generate. Controls two things: whether the kernel will generate core dumps for the process, whether the EOID, EGID should own the process's files in /proc. Processes are automatically made non-dumpable when their EOID or EGID is changed either via syscalls, syscalls that specifically modify those IDs, or via sysexecv when a set EOD or set GID program is executed. A process can change its own dumpable flag at any time by calling the new prctl set dumpable syscall. Yeah. This is essentially fixes the rest of this one. So let's say fixes. Okay, and then let's do the system server change so that at least system server spawn services are dumpable. System server make spawned process services. Processes dumpable after, yeah. This is so weird though. Like, I'm unsure what I think about this because now system server will essentially, it will fork, right, to spawn a new service. So it forks here, and then we do a bunch of setup, and then where is the dumpable thing? Right here. So we set up the sockets and file descriptors and stuff, get ready to execute the actual service process, and before that we set ourselves to dumpable. But this again creates that window in time where this process is owned by the new user ID. Because we've dropped privileges here from root, who normally runs system server, to the intended user, and the intended user now has full access to the memory layout of this system server fork. And because it's a fork, it will have an identical memory layout to the original system server. So I don't really like this. This actually seems like a mistake. So back up. Let's not do this. I'm not exactly sure what the correct solution is. I feel like maybe it should be almost like not an argument, but like something that is communicated via exec. Because what you really want to happen is that after exec, it becomes dumpable, but not before. Because if it is dumpable before exec, then we have a race here where you can basically use this as an information leak into system server. I don't like it. Yeah. So this information needs to be protected, and we should make it dumpable after exec. But we don't want to have to do this in every program, right? Like, you don't want every service to start a, hey, make myself dumpable. It would be much cooler if we had a way to change the behavior of exec so that it flips the flag. But anyway, we're not going to do that today. I'm going to think about it some more, and if anybody has some suggestions or ideas on this behavior, then I would be very interested to hear them. But yeah, we're going to stop here. I think we're erring on the side of caution today, so we're a little more restrictive. But root can still look at all the processes, of course. It's just that the normal user can't right now. So yeah, we'll stop here. So I think we made some interesting progress today, and just the fact that SU is now protected here is a nice thing. So shout outs to Brendan, of course, for the great bug report, bringing all of these things to our attention. I was not aware of this solution they have in Linux, and I quite like it. And PR set dumpable vulnerabilities. We should probably read that. Oh, holy moly. Okay, well, that's a lot. I'll read that offline. But, okay. I think we're done here today. So thank you very much for hanging out. I hope that you saw something interesting. And thanks to Brendan, and also to everybody who did the HXP CTF, who woke up my interest in security once again. I've been sleeping on that a little bit, so now we're getting back to looking at stuff like this, and it's a lot of fun. So thank you for reminding me. And Merry Christmas again, and I'll see you next time. Bye.